this video, we're going to be solving a system of inequalities by graphing. We've got a couple inequalities here. I'm going to graph them and color coordinate them so that we can see easily on the graph which one is which. I also have made notes over here. We're going to have to decide, with this being inequalities, whether we're going to use a dotted line or a solid line. When it's less than or greater than, the numbers that are on the line are not included in the solution, so that's when we use a dotted line. When we've got the less than or equal to, greater than or equal to part, then that means that the equations that are on the line will be part of the solution, so we want a solid line. All right, now on this first one, we're just going to start with this y is less than 4. Y equals less than 4 is going to be a horizontal line. It's going to be going through the y-axis at 4. So we're going to go to 4. 1, 2, 3, 4. We're going to look at the sign. It's a less than, so that means I've got to have a dotted line. So a horizontal line there going through 4. Now, with inequalities, we have to shade. So we've got to decide whether we're going to shade above the line or below the line. When it's a horizontal line or a vertical line, that's intuitive there, straightforward. I want the numbers which are less than 4. Well, on our number line, the numbers that are less than 4 are going to be below that horizontal line. Now, as opposed to shading everywhere, generally I just throw some arrows on there, reminding myself which way that I am going to be shading. Now, for the second one here, we're going to graph it in red. It is an absolute value graph, so we know it's a V. It has the positive coefficient 1 right there, so I know it's an upright V. So I can real quickly sketch this. The -3 is on the inside of the equation, so it tells me I'm going to go to the right 3 using my transformations. I've got a greater than or equal to, so the equal to part means I am going to have a solid line on this one. So I'm going to move that vertex 3 to the right. All right, I have a 1 coefficient there, so putting some dots up here with a slope of 1 just so that I'm a little more accurate when I draw this. Then our V is going to look something like this. Now again, I'm going to have some shading. Since y is on the left-hand side of the inequality by itself, then I can think of this as y is greater than or equal to this absolute value, so greater than is above. But to be a little bit more precise, if you want to test a specific value to make sure that you are correct there, let's just pick, maybe say 3, 2. If I pick that point right there, so I'm going to test the ordered pair 3, 2. The 3 is my x coordinate, the 2 is my y coordinate. So I can take that inequality, y is greater than or equal to absolute value of x minus 3. Plugging in the values, I'm going to have a 2 here for the y. I'm going to ask myself, is that greater than or equal to the absolute value of 3 minus 3? Well, 3 minus 3 is 0. Absolute value of 0 is 0. So 2 is greater than or equal to 0. So it does check it is a solution. So if one point above the inequality is a solution, then all of the points above it are also solutions. So again, just throwing some arrows in there to remind myself which way I am shading. Okay, now the overall solution to this system of inequalities is the part that gets shaded twice. So that is the inside part here. So if we're going to do any solid shading, I would probably only shade the solution part of this inequality. Makes the graph much cleaner and neater. A pretty straightforward Algebra 2 type question here where we're graphing to find the solutions for a system of inequalities. Definitely, thanks for watching. If the videos are helping, please share with your friends so they can benefit too. And don't forget to subscribe to the channel. Thanks.